slowly close down on the ball, fist, and now open it back up. And we have the ball. See? Now we can throw it.
Using computer vision to track human movement is an interesting problem for a lot of reasons. By tracking our movements and using these as input to a computer program, we open a whole world of human-computer interaction. We can use these movements to teach computers to move more like us, and we can transmit our movements over great distances nearly instantly.
To approach this problem, we combine the vision and spatial perception of an Xbox Kinect with the processing power of a computer. We used OpenNI, an open source library for the Kinect, in order to implement the basic skeletal tracking. With this, we were able to identify and track basic points like the shoulder, elbow, and hand. However, this alone wasn't sufficient for the kind of accuracy we wanted. We used easily identifiable visual cues like a pink glove in order to better track the other movements. With this, we were able to tell if the hand was open or closed, as well as extract additional information about its orientation. Once we identify key points on the body, we can use some relatively basic math to figure out the angles between them. However, when we need to translate these into servo angles, this can be tricky, because even though the robotic arms are decent approximations of human appendages, they aren't exact. We can move our arms in a variety of subtle ways that are impossible to reproduce on robotic arms.
This is a hard problem because computer vision-based approaches are inherently noisy. Tracking a specific point like a human hand is difficult, especially since we are used to moving our hands with great dexterity. When these movements are tracked in a noisy way and then reproduced on a robot, there is going to be some loss of precision and control. Fortunately, there are a variety of computational methods available in order to mitigate these losses. Our implementation of this works reasonably well. Even though fine movements are difficult to execute, the arms generally respond in the expected way. And while doctors won't be using this to perform remote surgeries anytime soon, it is sensitive enough to accomplish basic tasks like picking up a ball, with some effort.
Yeah, check it out.
Yeah. I'll move it around. I think we're good. We are good.